So the Cisco threat-centric approach to network security that we're looking at here actually brings in sort of a cyclical three-tier category that as security practitioners we have to think about. So first of all, hardening our infrastructure against new attacks is super important. So what is it that is acceptable for our organization as far as securing in the cloud or securing at the physical layer? Also, what is it that we're doing when we are recognizing or reacting to threats? How do we detect them? How do we contain them? How do we remediate them? And then after, we want to gain insight into what occurred if an event did happen. So how do we improve security for the future? How do we analyze? How do we improve upon our network? So this is something that's going to continue to evolve throughout our time at a particular location or at a particular site. And when we look at the threat-centric approach, sure, we look at before, we look at during, we look at after, and some of those things that we just looked at sort of go hand in hand with this. But one of the things that we can heavily focus in on is what is it that we are doing maybe before or during, and think about things like Cisco's Talus. So if any of you are not already familiar with Cisco's Talus threat intelligence, it allows us to be able to detect, analyze, essentially protect against any known threats and, of course, potential or emerging threats. So this concept of big intelligence allows us to be able to track our network. We're looking at endpoints. We're looking at virtual machines. We are looking at everything from HTTP and email traffic, and we're looking at what is normal. All right. It allows us to be able to not just implement security at the edge or in the cloud. This is all throughout our network infrastructure, and it allows us to be able to evaluate the environment. What is normal? And when things start to look abnormal, how do we dig deeper? How do we raise a flag? How do we start investigating further on what could potentially be happening, right? So we're looking for unusual behaviors that we can dig into in more detail. And we also have these cloud security domains, or just security domains in general. When we look at physical security, some big things that we often look at, whether it's our data center or server closets, is physical access. Do we have those fobs? Are we using things like biometrics to ensure that our physical hardware is locked down? Sometimes some of that's out of our control if we're in a co-location building, and of course when it comes to cloud. What about our network infrastructure? We've talked heavily about that with our infrastructure ACLs and implementing URFP and API security. So when we encompass this huge portion of cloud, we'll touch on some examples of that a little later. And then application security. So especially with regards to things like, is it on-premise? Is it off-premise? Does the endpoint that we utilize to get to this device traverse the network? So on and so forth. So these are all different security domains that are essentially things that we have to build into our design. And when it comes to cloud physical security, this is sometimes a tricky one. A lot of times we are relying on the third-party vendor, whoever the IaaS or the cloud provider is. If we're relying on the public cloud, what is it that they're doing to harden their environment? But many times when we look at this, we do want to implement maybe some multi-factor authentication, or maybe even just two-factor authentication. And the reason why is because we don't physically have the ability to incorporate biometrics or a key fob. So what additional layer of security is going to prove that it's us, right? So something like just a password is too easy to break. Also, when we think about things like cloud and maybe kiosks, which could potentially have cached credentials, we want to make sure that we are preventing that from occurring, if at all, totally eliminate it, making sure that we're using things like PKI certificates wherever possible. We touched a little bit about those data circuits, the physical cables that might be running between cabinets. How can we ensure that nobody is tapping that, and if they do, they can't infiltrate the data that's going across that wire. So we also look at this new acronym, or maybe it's new to some of you, called Cisco's SAFE. This is basically our secure architecture for enterprises, and it's a methodology that proactively incorporates security into the design phase. So we are looking at the edge, we're looking at the cloud, we're looking at the data center, and each one of these individual categories we often refer to as pins or places in the network that we are specifically trying to secure. So these pins, along with their secure domains, allow us to be able to try to push our network security policies even further. So what is it that we're implementing? Sure, we're implementing security in the management, and we are trying to follow compliance, and we are doing threat defense, and every single one of these layers adds to this stronger key. The stronger the key is, the less likely it is for somebody to be able to unlock the door, right? We want to avoid those bump keys. So remember that when we think about cloud, we have, of course, our endpoint, our network, our cloud. These are, many different layers or pins to our security. It's going to be a lot different securing our branch office versus securing the cloud, or maybe securing the network in the enterprise. Even, securing our endpoints. There might be a dedicated engineer specifically just to lock down cloud, or to just lock down endpoints, or to just lock down branch offices. We're going to have different policies for every single one of these.